Much ado, let's begin. Once again, you're welcome to physics live class. Here we're looking at lenses. We want to study lenses, and we want to see how objects, the magnifying or demagnifying glasses, can magnify an image can be formed with these glasses, and what quality of image can be formed. We have two major types of lenses. But before we talk about types of lenses, a lens is like just a piece of transparent glass that can be used either to diverge the ray coming from an object or to converge the ray coming from an object. It depends on which of these it can do. If it can diverge, meaning bring the ray to a common point, like as we're going to show from the board, it will be called a converging lens. If it can converge, if you can diverge, you call it diverging line, meaning spread them apart. If you can converge, meaning bring all the rays to a point, then it's called a diverging lens. So let's take a look at them. The first one is called the converging lens. A converging lens is a transparent piece of glass. Let me show from the board. Let's show. If I draw something like this, okay, let me erase. This is not good enough. Let me erase. Okay, so if I draw something like this, this is a converging lens. This one is a converging lens. Okay, this is a converging lens, and it has a line at the center. It has a line at the center, like this. Go to our summary note. The board is loaded. We can't wait for the board to load. Now, a converging lens is a transparent block which brings all the light rays together at a point. At that point, it's called the principal focus. So when you shine anything to a converging lens, different light rays to a converging lens, it will bring them at a point. It will refract them and bring them to a point. For example, let's take a look at this board. Oh, the board is still loaded. Okay, while waiting for you, let's keep explaining. So a converging lens is a piece of glass that can bring light rays together at a point, and that point is usually called the principal focus. That point where all the rays will be brought together to form an image is called the principal focus. Okay, and it does this. A lens does all of this by using the principle of refraction. Okay, the bending of light when it changes a medium. Light that is coming through the air, when it reaches the piece of glass called the lens, it's going to bend. That bending is called refraction. So all these are possible. Either the rays of light be brought together at a point or be spread apart. Be spread apart. Be spread apart. It's called refraction. It's either refract to meet at a point, or the rays of light refract to meet at a point, or they refract to be scattered to different locations. Okay, so that's what we call a converging lens, the one that can bring all the rays of light to meet at a point. Now we have what we call the focal length. When you study, for example, look at all these rays of light. This first ray of light coming from this object, this first ray of light, when it gets to the center, if you look at it, the refraction is taking place at the center. That was why I was drawing a line at the center of the lens. So when it gets to that center of the lens, you see this ray was refracted to pass through this point. Okay, it was refracted to pass through this point. And then it meets here. Now this ray that passes through the optical center is undeviated. Undeviated means it's not refracted. This ray that is passing through the optical center is undeviated, so it's not refracted. It will just continue to go in that straight way till it meets this point. Then the third one, the one that's refracted to pass through the focal point, This is a focal point. There are in principal axis. This line is a principal axis. This is what I wanted to draw before the bus started kept loading and unloading. This horizontal line that passes through the center of the lens is called the principal axis. Now, a certain distance from the lens, from the center of the lens to this place, is called, we put a point here, is called the principal focus. And the same exact distance away on the back side, on the other side, is also called the principal focus. Now, any ray that passes through this principal focus that hits the lens will be refracted parallel to the principal axis. Remember, this is the principal axis. This horizontal line that passes through the center of the lens is the principal axis, right? Now we say any ray that is passing through the principal focus. This one, can you see my arrow? Do you see my arrow at all? You're supposed to see. Okay, any ray that is passing through this principal focus, this red point before the lens, any ray that is passing through that point will be, when it hits the lens, it will be refracted to be parallel to the principal axis. So there are three rules of forming an object. We're going to write the three rules. The first one is any ray that passes through the optical center will remain undeviated, meaning it will go straight without being refracted. Then any ray that is parallel to the principal axis from the top, any ray that is passing from the top and is parallel to this principal axis, the horizontal line that passes through the center of the lens, any ray that is parallel to it from the top of the object, a line drawn, this green line that is parallel to the principal axis, when the ray hits the glass, it will be refracted through the principal focus. This principal focus will be refracted to pass through this principal focus on the back side of the lens. Then the third one is the one that is refracted that is coming through the principal focus, will be refracted. That is coming through the focal point, will be refracted parallel to the principal axis. So these three rays, they meet at a point. That point where they meet is where the image is formed. If you look at the image is inverted and is smaller than the object. The image is inverted and is real. It's a real image. Okay? It's a real image. It's not a virtual image. We're going to talk about the virtual image in the B part. Once the object is far away, a little bit far away, behind the focal point, once an object is kept a bit far away behind the focal point, then a real image will be formed on the other side of the lens. A real image will be formed on the other side of the lens. Now let's check our body face. Okay, our body is ready. Okay, let's say this is our principal axis. We draw our principal axis. Let's say this is an object. Let's say this is a candle light. This is a candle light. This is an object. Here is our optical center. This is the optical center of the lens. Okay. Now a ray that is coming all this way, let's change the color, maybe to purple. A ray that is coming like this all the way from here, parallel to the principal axis. You know the principal axis, right? This one is the principal axis. This line, this horizontal line is the principal axis. This is the principal axis. Okay, this is the principal axis. Okay, this is the principal axis. This long horizontal line. Now we say any ray of light that is parallel to the principal axis will be refracted, will bend. When it reaches the center of this lens, somewhere here, it will bend. Okay, Okay, it will bend. Like this will be refracted through the focal point. This point is the focal point F. Focal point F. Same distance away is also called a focal point on this side, F. Same distance away from the center, from the optical center, from this optical center. Let's assume this distance to the center of the lens and this distance to the center of the lens, they are equal. Now, this is the first one. Any ray that is parallel to the principal axis, like this one, this ray, any ray that is parallel to the principal axis will be, any ray that is parallel to the principal axis will be refracted on the other side through the focal point. Okay, this is the first rule for forming an image in a lens. This is the first rule. Now, the second one, maybe we separate them, right? It's better for us to separate them. Let's say we draw another lens. If we draw another lens, second rule, rule number 2. Let's say this is our lens also. This is also our lens. Okay, this is also our lens. And then we have we draw this line is usually broken line. This line that passes through the center of the lens, we represent it with broken lines. Okay. Okay. Now let's say the object is here. As usual. And the object can produce light, like candle, lamp, whatever, bulb. Okay, let's say here is our principal focus or focal point. You know, we have two focal points, one on the left side, one on the right side, F. We call them F, the focal point. The focal point. So this is the second rule number 2. We call this one number 2. Rule number 2 for forming an image by a lens. Rule number 1 is that any ray that is parallel to the principal axis, will be refracted to pass through the focal point. That's rule number 1. Now, rule number 2, what of a ray that is coming through the center like this, through the center of the lens. It will not be refracted, it will go straight. We call it all deviated. That's the second rule for forming an image. It will not be refracted, it will remain all deviated. Any ray that is coming through the optical center like this place, this center, that passes through this optical center of the lens will remain all deviated. This is rule number 2. Now let's take a look at the third rule for forming lens. Okay, the third rule. The third rule is we draw a lens again. Let's say this is our third lens. Okay, don't mind the inaccuracy of the drawing. Okay, just as long as you understand the point. So we have a broken line to pass through the center of the lens. Then we have the principal axis like this, a horizontal line passing through the center of the lens. Here is this optical center. We call it the optical center of the lens. Now, let's say we have a candle light or a lamp. As usual, we have the light here, the candle lamp or light, whatever you call it, is here. Produces the light ray. Here is our principal focus on the left side. And then here is our principal focus on the right side. Okay. Now the third rule says that any ray that is coming through or passing through the focal point, any ray that is coming through the focal point focal point. Okay, sorry. It has to hit the lens. Okay, it's coming through this focal point. Once it passes through this focal point, let's assume the focal point is here. Once the ray passes through this focal, we put our arrow to show. Then the ray will be refracted parallel to the principal axis. This one is kind of the opposite of the first one. Opposite of the first one. Look at the first one, the first rule. The first rule says, once the ray is coming parallel to the principal axis, to be refracted to pass through this focal point on the right side. The third rule says, if it's coming from the focal point, to be refracted parallel to the principal axis. Any two of these is enough to form the image. Any two of these rules is enough to form the image. Any two of these rules, but the three is okay. The three is the best, but two out of these three is enough to form an image in a lens. Two of these three rules enough to. So you must know these three rules if you want to know how images are being formed in a lens. If you want to know how image. Now let's look at how images are being formed in a convex lens, or what you call converging lens, right? These are converging lens. We already explained what is a lens from the beginning. These are converging. Now let's take a look at how images are being formed in a converging lens. How image is formed. So let's see how the image is formed. Let's see how the image is formed. Okay, now quickly let's take maybe this purple color. We draw a lens. This lens is looks like it's going to be too fat, so let's erase it. Okay. Okay, I think this one is proving a bit. So let's draw this lens. We'll just correct the drawing. Let's say this is our lens. Okay. This is a line through the optical center. Okay, we have F here, the principal focus here, 1.5 box to the optical center. Look at the optical center, 1 box and half, or let's assume this one also, let's say it's here, the second focal point, F. This is the first focal point, F. Now I want to put the object here, between F, object between, so first object, this object is going to be virtual object. Now object between between F and C. You know, these C are optical center. Object between F and C, meaning object between this. So object between this optical center and the focal point. So we see which kind of image will be formed if we do that. Which kind of image will be formed if we do that. Let's say the object is a candle light and produces some light rays, and this light ray travel through this place to hit the optical center. So you must show with arrow to show that the light ray is traveling towards the lens. Show with an arrow. So when it hits here, to be refracted to pass through the optical center. Okay, this is actually the optical center. To be refracted, don't mind my ray is bent, okay? Just for you to understand. It will be refracted to pass through the optical center, like this. Then, remember the any ray, we also say, let's change the color. Any ray that is coming through the optical center, because the light will also shine through this optical center. So we say any ray that is coming through the optical center will remain undeviated. These two rays will keep spreading out. Okay, we keep spreading out. They will not meet. They will not meet. They will be going apart. Okay, sorry. This one is going this way, and this one is going this way. They will not meet. Okay, they will keep going apart. These two rays, they will keep going apart. These two rays will not meet. This one is the wrong one. Okay, this is the correct one. Okay, they will not meet. Now, if you use broken line, if you bring broken line behind them, since they will not meet, they cannot form an image on this right side. So since they will not meet, they will not be able to form an image. So if we use broken line to bring them behind, the image will be formed as a virtual image here. So a converging lens can actually form a virtual image. A converging lens can actually form a virtual image when the object is placed between F and C. When the object is placed between F and C. So it will form the image here. We form the image of the candle light here, and it will be bigger than the object. To be bigger than the object. To form the image of the candle light here, and it will be bigger than the object. Why I use broken lines for the image? Because this image is a virtual image. It's a virtual image. It's not real. The image formed at this point is a virtual image. It's not real. Okay, so you can only get this type of image when you put the object between F and C. Meaning you bring the object too close to the lens. So you have a virtual image that will be as if it's on the same side as the object. Now let's list the three or four characteristics of the image. So let's say the characteristics of this type of image form, or properties of this image. Okay, the properties or the characteristics of this type of image that is formed by this converging lens. 1. Same side as the object. You can see the image and the object are on the same side. Same side. Normally in a lens, the image that is formed is supposed to be on the other side. The image that is formed is supposed to be on the other side. But this one is on same side. Okay? That's number one, property number one. Same side as the object. Number two is that the image is a virtual image. So we write the word virtual. What's virtual? Virtual means it's not It's not real, like you cannot see it. Okay? Is not real. You can't see. That's why we use broken lines. Okay? Cannot be formed on the screen. Cannot be formed on the screen. Okay? It's not where these two rays where they meet. It's not where they meet. It's actually just their projection behind. Just their projection behind. So it's a virtual image. Number three is that it's magnified. Number three is that this image is magnified or increased. Magnified. That's the third property. The third property is that it's magnified. The fourth property is that it's upright. The image is standing upright, meaning it's standing same as the object, like upright. In lenses, the images are usually inverted, but this one is standing upright. Okay, so these are the four upright. Okay, these are the four characteristics or properties of the image that is formed by the lens. When you place the object, whenever you place the object between the focal point and the optical center, when you place the object very close to the lens, whenever you place the object very close to the lens, then you will have this type of characteristics. Now let's go to the second type of image that can be formed. This is the first one. Okay, depending on where you put the object. Okay, number two, I want to put the object, so I will be using O for object. Okay, so that I will not be writing much. I will use O for object. Okay, so I will use O for object. So O between, meaning object between, oh, not between actually, object on, I can say between, on F. You put the object on F. What kind of image you going to get if you put an object on the focal point of a lens? Let's say your camera, you put your hand on the lens. What kind of object? You will not get an object. Let's do that and see. When you put the object on the lens of your camera, you will not see an object. Now let's see that. Let's say this is our lens. This is our lens. And this is our principal axis. Okay, this is our optical broken lines that broken line that passes through the optical center. Okay, this is our C, the optical center, this place. So we put C there, optical center. Okay. Now, this is my focal point. Let's say from here to here. Let's assume these are F on this left side. You know, we have two F, two focal point or principal focus. Either you call it focal point or you call it principal focus. This is the second F. Okay. Now let's say we put a light ray on F. You put the light, your candle or your hand or anything that breathes light, you put it on F. If you do that, now you will notice that you will not, let's notice the kind of object, the kind of image that will be formed. Now let's say we have a light ray that is parallel to the principal axis. The light ray is coming from here and is parallel to the principal axis to be refracted to pass. The rules are same for forming the image. Refracted to pass through the principal focus or the focal point. Then the other one that is coming also from this candle passes through the optical center. See, it's going like this. Remain or deviated. Now you can see these two lines become parallel. They cannot meet. They cannot meet. Even behind them, if you trace them backward, they will be parallel. So they form two parallel lines. So no image is formed. Why? Because you put an object on the lens. Parallel. These are parallel rays. They form a parallel ray and they cannot form an image. Parallel rays, they cannot form an image. Why? Because you are putting the object on the lens. you're putting the object on the lens. So whenever you put the object on the lens, you cannot find an image. Image cannot be formed. Okay, now let's go to condition 3. Condition 3, we're going to put the object behind the lens now. Behind the lens. Sorry, behind the principal focus. We're going to put the object behind. So number 3, I want to look at a situation or a condition where we put the object. Remember I say I'm using O for object. O behind the F. Behind F, meaning behind the principal focus. So if I put O behind the principal focus, what kind of image will I form? Let's take a look at the kind of image that can be formed behind. Okay. Let's take a look at the kind of image that can be formed. So as usual, we draw our lens. We draw our lens. Okay, so we draw our principal axis, which is the horizontal line that passes through the center of the lens. These are principal axis, a horizontal line that passes through the center of the lens. Now let's say our F is here. We change the color for F. So we say our F is here. And then let's say our F on the other side is here. On the other side is here. Now I want to put the object behind the lens. Behind. Meaning not on the lens. You know, in the first one, for the image, we put the object between F and C. The second one, we put the object on the F. The third one, we're putting the object behind the F. Behind F. Let's say this is our candle light. We're putting it behind the F. Okay, let's have our center line, vertical center line that gives us our C. So here's our C. Here's our C. Okay, now a light ray that is refracted, let's choose a different color to give us a clear understanding. A light ray that is refracted that is traveling, not refracted, that is traveling or be shine to the lens or shone to the lens will be refracted to pass through there. You see the rule is same. Be refracted, meaning we bend to pass through the principal focus. Okay, another one that is passing through the optical center will remain undeviated and go until it meets here. Until these two rays meet. Okay, my lines may not be 100% perfect, but the concept is what I want you to grab. How to do it. Because normally you're supposed to use ruler to draw these lines. Okay. Now, you see the two rays, they meet. Yeah. So you see the two rays, they meet. Now, where they meet, that's where the image is formed. Where they meet, that's where the image is formed. So the image of candlelight is formed here. And is inverted and is larger than the object. So we go to write the characteristics. We did write the characteristics for this one because no image was formed on the second one. We said it produces two parallel lines. So for this one, let's write the properties. So let me just use the word properties. Properties or characteristics of the kind of image that is being formed. On the kind of image that is being formed. Number one, we say on the opposite side, the image and the object. Okay, here we write image. We write image. So what is formed here is an image. So number 1, we write opposite side. The image and the object will be on the opposite side of the lens. Opposite side, not on the same side. So you can see the object is on this is O, object, and this image. Okay, you can see that the object is on the opposite side as the image, right? Both the object O, opposite side between O and I, between the object and the image, or not between, for the object and the image. They are on the opposite side. Both of them are. Number 2 characteristics is that it's inverted. The image is inverted. So I'll write image is inverted. Image is what? Inverted. You can see it's turning head upside down. Right? You agree that the image of this one is turning head upside down. Image is inverted. The image is inverted. Okay. Number 3 characteristics is that the image is real. This is very important in your exam. The image is real image. It's not a virtual image. We call it real image. We call it real image. That's number 3 characteristics. We call it real image. Number 4, the image is larger. Larger than the object, right? Larger than the object, or magnified. You can use the word magnified or larger. So these are the properties of this one. Now let's say the object is now placed. Okay, for today. Okay, let's quickly see if we can do like 1 or 2, and then we close it. Okay, we know we've done for convex lens. The concave lens will just show how concave lens is obtained. Okay, was it number 4? Yeah, because we've done number 3. When the object is behind F. Okay, when it's behind F. We put the object behind F. There, the next one is on 2F. There's what we call 2F. Object on 2F. Number 4. Object on 2F. When you put the object on 2F. O on 2F. Now let's draw a lens again quickly. Okay, if you check your textbook, they will not break it down like this. Anybody can confirm this. Most of the book will not break it down like this. But these questions can come in the exams. Okay, so let's say we have our lens as usual. Okay, this is the principal axis. A horizontal line passes through the center of the lens. Then let's have a vertical line that passes through that intersect the horizontal line into 2 equal parts. And that point where they meet is called the optical center C. Let's say our F is here on the left side, and our 2F is here. Okay, here our F is here. The circle principal focus is here. We call it 2F. And then we decide to put an object on 2F. Let's say we got a candle light on 2F. So we see that a ray from this candle that's coming to the lens, a light ray coming to the lens from this candle that is parallel to the principal axis will be refracted there to pass through the principal focus. Then another ray from this same candle that is passing through the optical center. That is passing through the optical center. That is passing through the optical center. We meet somewhere here. So you can see that the object, the image will be formed on 2F. On 2F, image will be formed. However, the image is same size as the object. The image is same size as the object. The image will be same but inverted. Okay? So this is image. I write capital I. And this is object, we write capital O. So when the object is on 2F, the image produced will be same size but inverted. So if you look at the properties, say properties or characteristics, same. And properties or characteristics, we say number 1, opposite side. O and I are opposite side, on opposite side. O and I are on opposite sides. Number 2, we say the image is real. I is real image, so is real. Number 3, we say it's inverted. But in the exam, you must know this. You must be able to remember them and state them. It's inverted. Number 4, same size. Same size. It's not diminished. It's not magnified. Same size. So these are the 4 characteristics. The last one for this lens is, what if we put the object beyond 2F? Beyond 2F. Say number 5. What if we put the object beyond 2F? O beyond 2F. So if the object is so far away and is beyond 2F, what will happen? Let's have our lens. Let's draw our lens. If the object is beyond 2F, okay, let's say these are principal axis. P, you can just call it P, principal axis P. Okay, we have our optical center. We have our optical center. Okay, these are F, first F on the left. This is 2F on the left. Okay, this F on the right. This 2F on the right. And let's say we put the candle light farther away. Let's say from here. The candle light is further away, so from here. So the light ray coming from this candle light parallel to the principal axis will be refracted to pass through the optical center. So I put an arrow to show that it's coming from this candle light object. We call it object. The candle light is the object, produces the light. So it will be refracted. When it reaches the lens, it will bend. The bend is called refraction. To be refracted to pass through the optical center. Okay, to be refracted to pass through this optical center. And sorry, to be refracted to pass through the principal focus or optical point, this one. Then another ray from the same candle light that is coming to, let's choose a different color, maybe something conspicuous enough. Another ray that's coming from this and is going to pass through the optical center. Okay, see, they will meet here. So let's take a look at the kind of object that is formed. You see, the object is smaller, right? Yeah, it's diminished. We say diminished. Sorry, I say object, the image form is diminished. It's very diminished, it's small. This eye image form. Okay, we call it eye image. Is diminished. So you can see the image, this is the object, this is the image. The image is smaller, it's diminished, although it's inverted. So if you look at the property, we can talk about it quickly. Properties. Now for this one, we say opposite side. O and I are opposite side, right? As usual. Both the object and the image are both on opposite side. Are on opposite sides. They are both on opposite sides. Okay, they are not on the same side. Now number 2, we say is real, is a real image. However, is diminished. Number 3, meaning it became smaller. Diminished. Diminished. Okay, and then number 4, which other one? Which other property? Opposite side, smaller, inverted. Number 4, inverted. The image is inverted. We are describing the image, okay? Everything. When we say diminished, we are talking about the image. So even if I don't write image is diminished, you should know that's what I'm talking about. The image is smaller, the image is real, everything is about image. Image is if I want to be writing that, it will be long sentences. Okay, image is inverted. So all I needed to write was just inverted, so that you understand. Inverted. The image is inverted. So this is for a convex lens. This is for a convex lens. So we studied the 5 different examples of the convex lens. Okay, so I think we stop here. In next class we do the concave. Concave is just one example, but that's why I wanted to just do it once and for all. But let me check. The concave is just one example. These young guys, they did it. These young guys, they don't have what we want. So okay, concave, maybe we can just okay, let me see if we can just do it, and then we say bye to it. Only one example concave have. A concave lens or a diverging lens. Okay, let's take a look at circle lens, which is called concave. The one we did just now was convex lens, and we did about 5 or 6 examples. Concave lens. They produce a virtual image. They don't produce a real image. They produce virtual image. Okay, and they look like this. They are thinner at the center. You know the one we did just now? They are thicker at the center. Convex was thicker at the center. Concave lens, they are thinner at the center. Okay, this is a concave lens. See, they are thinner at the center. So if I draw a horizontal principal axis, it's going to pass through this point. Okay, this is F. Let's say here is F. Okay. Here is F. And here is also F on the other side. Here. And let's say an object is here. Let's put an object, same candle light, between F and C. Okay, here is our optical center, C. So when light ray meets this, it will diverge, does not converge. Is that okay? The light will diverge, meaning it will be refracted away like this. To be refracted away. Okay? So another one passing through the optical center will remain deviated. The light that is passing through the center will remain deviated. Okay, so this one, we will bring the Broca component from here, from where this first ray meets the lens. We bring it down with Broca line as a continuous straight line to this side. So we bring it down, we see. So where they meet, where this Broca line meets, where it meets this ray, this ray, where they meet, it will produce the image there. Produce an image here. The image is virtual, so I'll use Broca line. So this is I, to produce an image. And this is O, the object. So this is for concave lens. So concave lens is a diverging lens. So when the ray travels and meets the lens, it will refract away. The one that is coming through the optical center, the light that is coming through the optical center, will also refract away. So we say these two, you extend this one backward with Broca line. Where it meets this ray that is passing through the center, where the two of them intersect, the object is formed there. And this image that is produced is a virtual image. So the image that is produced, so we look at the property. The image is virtual. So number one, we say the image is virtual, meaning it's not real. It's not real, okay? It's virtual. Cannot see it. Nothing is actually formed there. Okay, it's just calculations. So the second one is that it's upright. The image is upright. The third one is that it's diminished. The image, if you look at the image, is smaller than the object. So we can say diminished. So we say the image is diminished. The fourth one is that they are both on the same side. Object and image, same side. So I just write same side. So this brings us to the end of lenses. Our next class will be electricity. Okay, same side. So this brings us to the end of this class, and thank you for joining us.